Hi, welcome to our class today. We want to have a small discussion, uh, and our area of discussion is graphical method, graphical method of solving simultaneous equations. Graphical methods of solving simultaneous equation. Just a small recap from our last class. We know that solving a simultaneous equation, there are a number of ways that we can solve and get the values of unknown. We know we have the substitution method, substitution method. We have elimination, elimination method, and number three here is the graphical method. So already we've discussed the substitution method, elimination method, and I want us to have a short discussion on graphical method. So I'll pick two examples. I'll just pick two examples. Then we see how you're going to use the graphical method to solve that. And the first example is 2y, you subtract x equals to minus 10 and x plus y equals to 4. So I want us to solve this using the graphical method. There are ways that we can solve this. In graphical method, I can decide that I want to generate a table for each and every equations here. So I have a table for this and a table for the second equation. Let me call this one equation 1. This one I call it equation 2. So I generate a table for equation 1, then a table for equation 2, then I plot that and I get my graph. So we have a quick check on that. So we have 2y minus x equals to minus 10. Let me have a table for that. So we have a table here, x, y. Then I have the values here. I can just have three values, 0, minus 1, and we have 1 here. So I get the values of y. So if I put uh, minus 1 here, this my equation will be 2y minus 1 because x is minus is equals to minus 10. So this will be 2y plus 1 is equals to minus 10. So that the equation will be 2y equals to, when I take this one to the other side, it will become minus 1. So minus 1 minus 10, this is minus 11. Then I divide both sides by 2, and my answer will be y is equals to minus 5.5. So this is minus 5.5. That is the first value there. What about when x is equals to 0? I'll come and do the same thing, that 2y minus 0 uh, is equals to minus 10. If I take this one to the other side, nothing will change, so that I'll have y is equals to minus 10. If I divide here by 2, I divide here by 2, y will be, by that one will cancel each other, by this one, by this 5. So here it is minus 5. So the first coordinate is minus 5. Then when x is equals to 1, what will be the value of y? So 2y minus 1 equals to minus 10. So we have 2y. If I take this one to the other side, it will be addition. So that will have minus 9. Then I divide both sides by 2. Y will be minus 4.5. So here you have minus 4.5. So we have the three coordinates for the first equation here. Three coordinates for that. Then we have the second one for this one. I'll have generate a table for that. X plus y equals to 4. Again, we have a table for that, X and Y. We generate a table for that. I'll pick three values, 0, minus 1, and here you have 1. Here I put minus 1. I'll have minus 1 plus y is equals to 4. Uh, if I take minus 1 on the other side, it will become addition. So the value of y will be 5. The second one, so this one is 5 here. The second one is when x is 0, y will be x, where there is x, I write 0. So you have 0, you add y is equals to 4. So my y 0 plus y is y, so y is equals to 4. So you have it as 4 here. Then lastly is when x is equals to 1. So I will have x, or I write minus 1, just minus 1. Is it minus? It is just 1. When x is 1, I add y is equals to 4. But I take this one to the other side, it will be y is equals to 4 minus 1. So that y will be 3. So the value here will be 3 for that. So we have the table for that. We have the first table and you have the second table here. If I pick the coordinates for the first table, so here you have coordinates for the first table and the second one. The first table, it is minus 1, minus 5.5. You have 0, minus 5, and the other one is 1, minus 4.5. And the second table, the values here are minus 1, 5. You have 0, 4. Then you have 1, 3. So you have values like that. So if I come and plot these values, my graph is there. Let me change the scale of the graph so that we start plotting these values. Minus 1, minus 5.5, the first coordinate is minus 1, minus 5.5. So let me have that minus 1, minus 5.5. Minus 1 is here, minus 5.5 is supposed to be a value somewhere here. So you have like that. I think this point is supposed to move slightly below that. The second one is 0 minus 5. 0 minus 5, I have 0 minus 5. I have the second coordinate. And the last one is 1 minus 4.5. 1 is here, minus 4.5. So the value is supposed to be somewhere there. So we have a line. I draw the first line here. We'll come and draw a straight line that is passing through the three points here. So that is how my line is supposed to look like, a line that is passing through the 3 points. So you have our line here that is passing through the 3 points. The second line is one is supposed to be more accurate. So I will sketch the line that is supposed to pass through C. So I have it like that. The second point is minus 5, minus 1, 5. We come and plot that. Minus 1, 5. 5 is up here. Minus 1, 5. So I have it here. Minus 1, 5. is supposed to be somewhere here. Minus 1, 5, the coordinate will be somewhere there. The second one is 0, 4. 0, 4. 0, 4 is supposed to be somewhere there. And lastly, we have 1, 3. 1, 3. 1, 3. It is found uh, somewhere there. So I use a straight line to draw that. So I'll have a straight line that is passing through the 3 points. So I have a straight line passing through the 3 points, right? Sorry, this point is not supposed to be there. The 3 points, the other point is supposed to pass through that. Correct. Now, how do I get the solution for that? The solution for my graph is found where the two graphs are intersecting. The solution is found here. If I have this graph, let me give it another color here, but I have it like that. So you have the first line and you have the second line. So where they are meeting, that is the coordinate that I want here. So I'll come and select the points where the two graphs are meeting, and you can see how accurate that is. But for me, I'll pick just values that are, I'll round off this one because this one is too smaller. I'll pick to the nearest one decimal place. So if I pick that value, the graph here is 5.9 and negative 1.9. So I'll come here and say where the graphs are meeting is 5.9 and you're having negative 1.9. Now, this is now the solution for that. This one, 5.9, represents the value of x. So x is 5.9 and y equals to negative 1.9. And therefore, we have solved this simultaneous equation using the graphical method. Using the graphical method. If we check in our graph, we can tell how this one is. We can be able to see that 5.9 is a value. It's close to 6, but not yet there. Negative 1.9 is close to 2, but not yet there. So that is the solution for the first equation. We have the second method that I can use to solve the same problem. And this method, it is a method of checking the x-intercept and y-intercept. If I have a graph that looks like that, a graph, this one is x-axis, this one is y-axis. I can also use that method to try and get the values of x and y, the values of x and y. In x and y intercept, I will come here and ask myself, where does this graph pass through? If the graph is passing through that one and you're having another one passing through that, this point, because this y axis and this one is x axis, this point is called the y intercept, and this point y-intercept, and where the graph cuts this axis, we are calling it the x-intercept. So this is the y-intercept and this is the x-intercept. The same case, this one is, because this graph is y, I'll call it the y-intercept, and this one, because it is x, I'll call it x-intercept. So I can come and solve the same problem using this idea of x and y intercept, which is a bit a shorter method. So I want again to solve this the same problem, but now using this. So I'll come here and have 2y I minus x is equals to minus 10. Let me call this one method 2. This was method 1. Uh, method method 1. So I want to solve the same problem like the way I've solved to see whether the answer will be close to this, because this is our answer. These are our answer answers for that. So I will come and the first line, this is the first equation, and so is the second equation. For this is one thing that I should note, that if I'm given an equation as 2y minus x is equals to minus 10, we have minus 10, then we have the x intercept, and you have the y-intercept. I want us to have a short observation. What happens on x-intercept? Let me go back. If I pick any point on x-intercept and y-intercept, if I pick a point here, this one, and I pick a point somewhere here, I pick 2 points on either side, and even here. Now, let me check the coordinates of A here. This is, which intercept is this? This one is, because it's on our x-axis, this is the line here. If a line passes through here, this one is the x-intercept. So if I check the coordinate here, let us look at the coordinates of A. On this point, coordinates of A, just have a table for that. If you look at the coordinates of A, for this is on x-axis, and even this one on x-axis, and even this one on x. The other point is this one D, which is on x-axis. You can see that on x-axis, negative 4, 0. Even this one, 3, 0. So the values of y is always 0. So at x-intercept, the value of y is equals to 0. So I'll come and substitute here that at this intercept, the value of y is 0. So I'll have 2, 0 into bracket, then I subtract x is equals to negative 10. The whole of this one will turn out to be 0. So negative x is equals to negative 10. Therefore, negative and negative, they will cancel each other. So the value of x is equals to 10. So this graph is passing through 10 on x-axis, passing through 10. I want to do the same thing. I want to know where does it cut the y-axis. I will come here and say at y-intercept, intercept, intercept, I'll come and say that x, the value of x is 0. So I am interchanging this, and we can be able to see that one from our graph. Y-axis, the value of x is 0. The value of x is 0. So you can see 0. This B and C. Here you have 0 and 0. This is the value of x. This is the value of y. The two of them are 0. So I'll come and put in the same equation. Come and say that 2y minus 0 is equals to minus 10. I am putting in this first equation. So that I will have 2y is equals to minus 10. If I divide here by 2, the value of y is minus 5. So this is where the line passes through. So I will have, actually this one is, I'll go to my graph where you have minus 5, this one, or even I can pick this one to become as a coordinate. So 0 minus 5. So I've picked that one and that. 0 minus 5. And for this one, 0 and 10. So you begin with the first one, 10, then you're having 0. So I'll just plot these 2 points. I will do the same thing for this one. X plus y is equals to 4. This is the second equation. I start with x-intercept at x-intercept intercept. At x-intercept, the value of y is 0. So I'll have value of y is 0. So where there is y, I'll be putting 0 in my case. So I'll come and say x plus 0 is equals to 4. So you can see that x is equals to 4. The second one, at y-intercept, the value of x is equals to 0. So I interchange that. So I'll say 0 plus y equals to what? 4. So I'll have like this, so that the value of y is equals to 4. So let me come up with the coordinates. The first coordinate is this one and that. So I'll have 0, 4. And the second one is 0, 4 again here. This one is supposed to be, y is the one that is 0. So that y is the one that is 0 on that. So let me interchange. Y is 0, so 0. Then this one is 4. Then this one, x is 0 and y is 4. So you have it. I hope for this one you've also done the same. The value of y is 0. So let me interchange this one. This is supposed to be is supposed to be like this. So I'll come and I just want to clear this one. Let me clear that. So we have this is our y. So the first coordinate we picked this value, and we picked this one. So 10, 0. So this is supposed to be 10, 0. We've picked that. And 0, negative 5. 0, negative 5. So come and have 0. Then you're having negative 5. So we want to plot these two. This is our 0 in this case, and we want to plot that. So I'll come to my graph and plot the same values here. Come to my graph and try to plot the same values, right? So the first is 0 minus 5. You have 0 minus 5, 0 minus 5, 0, 0 minus 5, 0 minus 5 is supposed to be that point. Let me put 0 minus 5. You have it there. Then 10, 0. So you have 10, 0. You have 10. Then you're having 0. You have it value like that. Then we draw a straight line that is passing through the 2 points. So you have it like that. You have passing through exact point. So you have like that. The second point is I pick 4, 0. So you have 4. I increase my graph 4, 0. So you have 4, 0. Then the other one is 0, 4. 0, 4. So you have 0, 4, 0. Then you have 4 somewhere here. So you have just the 2 points. Then you draw a line that is passing through that. So if I draw a line that is passing through that, that line is supposed to be a value like that, a value that is like that. Then now we just get the solution as usual. Solution for that. I'll come and ask myself, where are they intersecting? You can see the value here is 6 minus 2. 6 minus 2. 6 minus 2 for that. The point of intersection is 6 minus 2. So I have my answer as 6 minus 2. So you can see the answer is almost the same, because if I round off this one, this answer, it will be 6, the nearest whole number. This is approximately 6. This is approximately minus 2. So the answer here, the value of x is equals to 6. The value of y is equals to, let me have this one. The value, we have it here. The value of x, the value of x is equals to 6. The value of y is equals to minus 2, because the first value here represents what we have on that. So that is how you're supposed to solve that. It's a graphical method of solving simultaneous equation. You can see we have used our graph to solve the problem here. So this is what you have. You can pause, then you observe what you've done here. This is method 1. Method 1 is here. Then you're having method 2. So you can be able to follow this. Just know that at x-intercept, the value of y is 0. At y-intercept, the value of x is 0. So you just follow that procedure. Then you work out that. Where they are meeting here, that is where the solution is. You get for me the coordinates for that. Right? So I will leave 2 examples. You try to solve using the 2 methods. So I can give as part of just assignment. I will leave one. You solve this one. X plus 2y is equals to minus 20, and y minus x equals to minus 5. Actually, this one is enough. But if you have time, you can also attempt this one. X minus 2y is equals to minus 60. Then x plus y is equals to 0. So you can use the 2 methods to try and get the answer for that. Right.